Welcome, you guys. So in this section, we are going to do polynomial long division and synthetic division, and we're going to use it within a few theorems here, okay? So I found that it's almost like long division isn't really being used that much anymore, like it used to be. As we advance more in technology, I feel like calculators are given sooner, and so it's not as emphasized. So I'm actually going to go in and do a regular long division problem just to kind of ground us. Maybe some of us need to be reminded because it's been a while. I mean, gosh, that was probably like fourth, fifth, sixth grade, somewhere in there. And then for those of us who maybe didn't learn it, here's your crash course on it, okay? So let's talk about the terminology, because we will be using these terms, a lot throughout this section. And we learned these so long ago that we've probably forgotten them. So the number outside of the box, that's going to be your divisor. The number inside the box is your dividend, okay? And then the answer when you get done is called the quotient. And most people remember that the leftovers is going to be the remainder. So this is always here for you if you need to come back and remind yourself, all right, what are these pieces called? All right, so we're going to do a long division problem so that we can see that polynomial long division is analogous to division with numbers, okay? All right, so we're going to put 3014 inside the box, okay? That's going to be our dividend, and we're going to put 9 outside. Now, normally you would ask yourself, does 9 go into 3, the first number? But 9 doesn't go into 3, so we actually move over a notch and say, does 9 go into 30? It does. So we'd say, okay, how many times? Well, 9 times 3 is 27. So I don't put the 3 here. I put the 3 above the 0. And that's going to be important because placement with our polynomials is also important, because it's going to tell us when we've reached the end, okay? All right, and then after you find that, you actually multiply these two numbers by each other. So 3 times 9 is 27. And I'm going to phrase things differently than we did when we were, maybe in fourth grade or whatever. I'm going to say, and we're going to change the sign instead of saying subtracting, and you'll see why. Normally you would subtract here, but I'm going to say multiply and change the sign. So now it's negative 27. So if we subtract, we'll get 30 there, or 3 there, sorry. All right, so we got to bring down the next number. And now all the math is done down here. So how many times does 9 go into 31? I think it'd be the same amount, because 3 times 9 is 27. Don't forget, change the sign. So 31 minus 27 is going to be 4. Bring down the next number. 9 into 44. Well, let's see here. 9 times 4 is 36. So multiply, but change the sign or subtract. Okay, so we've reached the end, okay? We're at the end up here. This is all lined up. Sometimes you'd add a 0.0 and you'd keep dividing, or you'd make a fraction out of this, okay? All right, so if we're to name these, this is going to be our quotient. Just checking that we remember. This is going to be our divisor, our dividend, and our remainder. Now, normally in the last textbook that I had, they would have you write this as the quotient as 334, and you put the remainder over the divisor. So my old textbook did do this. I noticed this new one, the Pearson one, doesn't, so I'm actually not going to write it that way. Pearson wants to make sure that you understand that 3014 can be rewritten as multiplying these two numbers by each other and adding the remainder. That should get you 3014, right? So if we do 9 times 334, that's too small, but when we add the 8 in, add the remainder in, bam, now we're at the 3014. And that's important because that's how you can go and check your answer. If you're like, because this is going to be a little abstract. So if you're like, is this right? Well, you're going to use this same idea of multiplying these two and adding the remainder. All right, so let's go ahead and dive in. Okay. In each of the following, a polynomial p of x and a divisor d of x are given. Use long division to find the quotient q of x and the remainder r of x when p is divided by d of x. Express p of x in the form dx times qx plus rx. All right, so that's a lot. That's why I wrote these directions down. This is actually the exact directions that your homework uses, you guys. And so I wanted to make sure that I copied it because it's a bit wordy, right? So I just want to make sure we understand it. Okay, so we're basically taking p of x and we're dividing it by x minus 3. So basically we only care about the front terms, okay? In our mind, we're saying x, that front term, multiplied by what gives you x squared. Okay, so you have to figure out what you would multiply it by, right? So it looks like it would be just an x. We put an x in here, x times x gets us x squared. Now I'm not going to place it right here. You want to keep things lined up. You never want to put an x to the first on top of an x to the second. You never want to put a linear term on top of a quadratic term. So you're actually going to write it over here and keep things all lined up. X to the first on top of x to the first. All right, after we get that number, if you recall, right, going back to this example, after we got the 3, you do 3 times 9 and you write it down here and you change the sign. So that's what we're going to do. We're going to do x times x to get us x squared. Change the sign. And then we're going to do x times negative 3, which is negative 3x, but you have to change the sign. Okay, now this whole sign changing. Well, if you don't change the signs, let's just because I want you guys to be able to pick what you like better. So there's our x squared. This is how textbooks do it. There's our negative 3x. But because we are subtracting this quantity away, the negative sign will distribute into the parentheses, changing the signs on that. For me, this gets a little crowded, a little hard to see what's going on. But if that's what works best for you, do it. Do whatever works best for you. So for me, I just always change the sign. So I'll say, okay, x times x is x squared. Change the sign. X times negative 3 is negative 3x. But because I'm subtracting a minus minus, we'll change the sign. All right, the first one should always cancel. And then we're going to add downward. Now remember, after we subtracted, we had this 3, right? We had to bring down the next number. We had to bring down the next digit, which was 1. So we're going to go ahead and bring down the next term in this case. I probably accidentally said term when we were doing numbers, but all right. So we brought down the next one, and it's still all about the fronts again. It's still all about these. We want to say x times what gets us 6x. X times what gets us 6x. And so you can see that x times 6 would get us 6x. So a positive 6 is going to be the next thing. And you can see we've reached the end, so we're done. We just have to make sure that we distribute. So 6 times x. Don't forget to change the sign. And a positive times a negative is negative, and 6 times 3 is 18. So it's negative 18. We got to change the sign. So that's going to get us 6, you guys, when we end up subtracting. Okay, so here's where we're at. They say to write p of x as d of x times q of x plus r of x, right? So let's do that. All right, so x squared plus 3x minus 12. The divisor, the d of x, is that, which you can see in the directions, right? So it's going to be x minus 3. And then we have to multiply that by the quotient. Well, remember, the quotient is the answer. So we're going to multiply it by x plus 6. And then you have to add in the remainder, which we know is down here at the bottom, right? Oops, I just wrote r of x. How about writing, what is that, a 6? Okay. Now, what you can do that's kind of cool once you write it this way is you can go in and check. It's like, you better believe I want to check the signs on these. Get students so badly. And I'm not gonna lie, get me too sometimes, right? So I definitely want to go in here and check and make sure I got it right. And how cool is it that we have the ability to check? When you get that chance to check things on, especially on a test, do so. So if you finish your test early, right? Don't leave your classroom or don't sign out if you're doing it online, right? Check it, make sure that it actually works. So we got x squared plus 6x minus 3x minus 18 plus 6. Well, when we combine these two, we're going to get a 3x. And when we combine these two, we're going to get a negative 12. And you can see that that matches the original dividend. So this indeed checks out. If you have a multiple choice test, how easy would it be to just take all the answers and FOIL them out and see if they get you the original? All right, let's try some more. So this one, we need to rearrange first. You can't just throw this guy into the box, okay? Because he's all out of order. You've got to make sure that whatever you're writing is in descending order. So our p of x needs to have the x cubed first, then the x squared, then the x to the first, and finally the plus 2. Okay, so we're going to go ahead and put this new rearranged p of x in as our dividend. And then we've got our divisor. Okay, so it's all about the front terms, right? So we want to ask ourselves 3x times what gets us 9x cubed. All right, so let's see, we're going to need another 3 to make the 9 and 2 more x's to make 3 x's. So I'm going to put the 3x squared above the other x squared. Put the quadratic term on top of the other quadratic. So if we multiply here, we're going to get 9x cubed. We'll change the sign because we're subtracting. And then we're going to get 3x squared. Don't forget we're subtracting, so change the sign. So it's going to give us negative 21x squared. We got to bring down the next term. And then we do this again. Look at the fronts. So we're saying 3x times what gets you negative 21x squared. So 3x times what gets you negative 21x squared. So let's see, it looks like we're going to need a negative 7 to make the negative 21 and 1 more x to get 2 x's. So negative 7x has to multiply or distribute it. So negative 21x squared, but since we're subtracting, it's going to be minus a minus, so change the sign to a plus. And then a negative 7x. Let's change the sign since we're subtracting. So that gets us 6x, and we'll bring down the 2. It's all about the fronts. So 3x times what gets us 6x? 3x times what gets us 6x? Looks like all we need is just a 2, right? So 2 hits the 3x to give us 6x. Change the sign. 2 times 1 gets us a 2. Change the sign. We actually have no remainder on this one. So if we were going to express this, how they want us to express this, as p of x equals the dividend times the quotient plus the remainder, then we would write this as 9x cubed minus 18x squared minus x plus 2 can be found by taking the divisor, multiplying it by the quotient we just got, and then adding in the remainder of 0. All right, so of course we're going to check it. Let's go and see if we got this right, you guys. You know, I trust myself very little. I always tell my students, I don't know if I could get 100 on my own test. I feel like I have to make some sort of bonehead error, you know? Like my favorite one, like 2 times 3 is 5. You know, today 2 times 3 is 5, right? Just something like that. Okay, now distribute the 1 in. And then, oops, don't forget the remainder. In this case, it doesn't matter. All right, so this is going to be 9x cubed. Then we're going to take our x squared terms, negative 21 and positive 3 make what, negative 18? And then we're going to take our linear terms, our x to the first 6 minus 7 is just negative 1. And then we got a 2 plus 0, which is just 2. And that does match the original dividend, so we're good. I probably won't check them all now that you understand how to check it. Let's go in and do one that requires a little bit of stuff at the front also. So when you're doing, whether it be long division or synthetic, which we're going to learn in a second, you have to make sure that every single term is represented. In this case, the cubic, the quadratic, the linear, and the constant. And you can see that our dividend is missing the x squared term. So what we have to do is we have to add a 0x squared in this case, so that way every single term is present. Every single exponent, in other words, 3, 2, 1, and then none. You need everybody to be there. So that's what we're going to place inside for our dividend. Got to remember to have that 0x squared, basically serving as a placeholder so that everything lines up nicely. Okay. In synthetic division, if you don't have it, it'll be disastrous. Here you might notice, oh, I'm missing it because the terms won't line up. Okay. All right, so it's all about the fronts. So we're looking at x and x cubed. So the question is, x times what gets us x cubed? Well, it looks like we're going to need 2 more x's to give us a total of 3. So x squared times x is x cubed. X squared times negative, oh, I forgot to change the sign, right? And then x squared times negative 4 is negative 4x squared, but don't forget to change the sign. So we end up with 4x squared. Now we're going to bring down our next term. All right, so now if we look at just the fronts, we're saying x times what gets you 4x squared. X times what gets you 4x squared. So it looks like we're going to need a 4 and 1 more x to give us a total of 2 x's. So plus 4x. So 4x times x is 4x squared, change the sign. And 4x times negative 4 is negative 16x, change the sign. That's 6, a little more obvious. These cancel, we get 3x when we add downward, going down the next term. So now we want to say x times what gets you 3x. X times what gets you 3x. So it looks like we just need a 3. So 3 times x is 3x, subtract. 3 times negative 4 is negative 12. Change the sign because we're subtracting. Again, oh wow, all these are ending up being remainder zeros, huh? Okay, I'll take it. Those are the easiest ones. So if we were going to write this in the form p of x equals the divisor times the quotient plus the remainder, it would look like this. The divisor is x minus 4. The quotient is x squared plus 4x plus 3, and the remainder is 0. Of course, you could go in and check that and make sure it indeed checks out. Okay, so we had 3 examples of long division. Hopefully that is enough. I'll try to see if I can put in the link down below, maybe some more examples for you guys. All right. So now we're going to move on to what is basically the easier version of division. Okay, now you can't use it on everything, so that's why we had to teach you long division. Okay, so the divisor, sorry, has to be of this form. It has to be x to the first, and it has to have no leading coefficient. So if I go back and I look at the examples that we did, okay, let's look at them all. I could use it on this one because there's no leading coefficient and the exponent is 1 on the divisor. So we could use synthetic on example A. We couldn't on example B because of this 3 in front of the x. We could on example C because there's no leading coefficient, or the leading coefficient's 1 and the exponent is 1. Okay, so, but a lot of times, let me see if we have any examples in here. I don't think we do. But a lot of times we're dividing an x cubed by an x squared even. And so you couldn't use it on an x squared. So let me just kind of make sure that we understand. For synthetic division, things like this, right? Or maybe things like this as being our divisor, these would not be allowed. It has to be something like x plus 7, x minus 2, something where the leading coefficient is 1 and the exponent is 1. So the problem here is the 3 and the problem here is the 2. So the divisor has to be written in the form like this. Okay. All right, so here we go. Oops. So this one is of that form, this divisor. So we can use synthetic division. Now, basically what you're doing is you're taking the divisor and you're setting it equal to 0. So if you move that 2 over, it would be negative, right? To figure out what's going to go inside the box. In other words, just always change the sign. It says plus 2, then you're going to do a minus 2. Now, we're not going to use any variables in synthetic division. We're only going to use the coefficients, and we're going to write those down. So in front of the x cubed is a 1. In front of the x squared is a negative 4. In front of the x is a 3, and our constant is 2. So we basically just wrote it down without the variables there. Now you always have to drop down the first number just to get the ball rolling. And from then it's multiply, add, multiply, add, multiply, add until you get to the end. So what we're going to do is we're going to multiply these two numbers by each other. So negative 2 times 1, that's going to get us negative 2. So we're going to put negative 2 right here. And then we're going to add downward. So negative 4 plus negative 2 is negative 6. Now we're going to multiply these two by each other. So negative 2 times negative 6 is 12. So we're going to put a positive 12. We're going to add downward to get 15. Now we're going to do negative 2 times 15 to get negative 30. And so 2 plus negative 30 is going to be negative 28. And that last number, that's our remainder, okay? All right, now it's time to put the x's back. So if we put the x's back, this is actually going to be 1x to the, now, you divided an x cubed by an x to the first. So that's going to make this an x to the second. If you want to think of it this way, you always down the highest degree by 1. So if you started off with the cubed, you're going to end with the squared, okay? So 1 minus 6x to the first plus 15. So basically, once you have that first 1, you just go down by 1 on all of the ones that go after it, okay? All of the succeeding ones. Okay. All right. So the negative 28 is going to be the remainder, right? Okay, so let me just really quickly take a peek to make sure I know how your homework in our class is having you write this. Oh, it's just having you identify what the quotient is. So on the homework on my math lab, they want you to write down the coefficient. Now, typically we don't write the 1, you guys know that. So I'm not going to write the 1. And then the remainder, r of x, is just the negative 28. Okay. All right. Let's try another one. I love these. All right, use synthetic division. Okay. So in this one, we did this earlier, by the way. I think this is the same one. We'll give them a check. It is. It's this one, right? So we're going to do it using synthetic division. So remember that divisor, we're going to set it equal to 0. So it's actually negative 4 that's going to go inside the box. Now, everybody has to be represented. Again, this one's missing the x squared term. So you need to make sure that when you write it in, that you are writing it in with a 0x squared. So it would be 1 for the x cubed, 0 for the x squared, negative 13 for the linear term, and 12 for the constant. All right. So multiply, add, multiply, add. So we're going to multiply to get negative 4. And we will add downward to get negative 4. We're going to multiply negative 4 times negative 4 to get 16. And we'll add downward. Negative 13 plus 16 is 3. We're going to multiply to get negative 12. And we add downward to get a remainder of 0. So if we were to put the x's back, it goes down by 1. It was degree 3, so now it's degree 2. So the quotient, in other words, the answer, is x squared minus 4x plus 3. And the remainder is 0. All right, and we're going to continue to do synthetic division. So if you're like, that wasn't enough for me to master it, the rest of the class is pretty much us doing, or the rest of the notes here is us doing synthetic. So you will get good at it, okay? All right, is 8 a factor of 32? Why or why not? So some people will say yes, because 4 times 8 is 32. So that's perfect, okay? Because of the section that we're on and where I'm trying to go with this, I'm going to phrase it differently, but that's a perfectly fine answer to that question. So I'm going to say 8 is a factor of 32, since the remainder is 0 when we divide. Okay, so if you took 32 and you were like, hey, let me divide that by 8, you'd say it goes in 4 times. So yes, it's a factor. The next one says, is 8 a factor of 34? Well, if we tried that same division, it'd be 4, but this time we'd end up with a remainder. So we're going to go ahead and say it's not a factor, since the remainder is not 0, right? All right, so basically, to sum it up, a number is a factor of another number if it divides it evenly. In other words, if the remainder is 0 when you divide. All right, so we look at this question. It says, determine if the binomial is a factor. So we just have to divide and see if the remainder is 0, right? That's going to be our plan of attack, okay? If the remainder is 0 when we divide, then it is a factor. All right. Let's go ahead and try this, you guys. Now this one, we can use synthetic division because the front coefficient is 1 and the exponent is 1. So we are good to go And it's going to be -3 that goes in the box because we set it equal to 0. Let's do an exponent check. 3, 2, 1, and then none. All terms are represented. All exponents are represented. So we don't need to add any zeros on this one. Multiply, add, multiply, add, multiply, add. So we're going to multiply to get -9. We're going to add to get 1. We're going to multiply to get -3. We're going to add to get -4. We're going to multiply to get 12. We're going to add to get remainder 0. So our conclusion is, since the remainder was 0, x plus 3 is a factor of the polynomial. Okay, let's try another one. Okay, same exact polynomial, but this time it's going to be a -2 that's going to go in the box where the divisor goes. Multiply, so -2 times 3 is -6. Add downward. Multiply. Add. Multiply. Add. So since the remainder was not 0, x plus 2 is not a factor. Okay. So we've already learned in this class how to find f of c. You know, for example, if I said, okay, guys, find f of 3, that would mean that you would just plug 3 in for x, right? Okay. But we're learning a second way to do it. The second way to do it would be divide by 3, and the answer is the remainder. Okay, so I'm going to put or divide by 3. And f of 3 is the remainder. So we now have 2 ways to do this, okay? And it's nice to know both, because sometimes this way is easier, sometimes this way is easier. So let's go ahead and take a look at this in action. So we're going to do f of -2, the old way and the new way. Okay, that's what I'm going to call it. Old way and then the new way. Okay, so let's go ahead and substitute -2 in to the function. All right, -2 squared would just be 4. So this is going to be 4 times 4. -8 times -2 is 16. 4 times 4 is 16. All right, I'm going to do my positives. So 16 plus 16 is 32. If I do my negatives, -8 and -6 make -14. And let's see, 32 minus that is, I believe, 18, you guys. So f of -2 is 18. That was not exactly easy. Let's try this new way and see. So -2 will go into the box. Don't change the sign on it, you guys, because there's no x like -2 to set equal to 0, right? You just use the number as is in this case. So 1, 4, -8, and -6 are all the coefficients up here. So we'll bring down the 1 to get the ball rolling. -2 times 1 is -2. -2 times +2 is -4. We add, we get -12. And a -2 times a -12 is a +24. There's our 18. So f of -2 is 18. I think on that one, I actually liked the synthetic division better. Interesting. Okay, so it's good to know both. If the math starts getting pretty hard, maybe with the old way, then think, well, let me just do some synthetic division. You're going to get so fast at synthetic division because we're going to use it so much, okay? All right, find f of. So let's use this new way, because can we agree substituting 1 minus the square root of 2 in for all the x's? It sounds pretty bad. I mean, even as is with the synthetic division, this isn't going to be super awesome, but I think it'd be worse if we substituted it in, you guys. Okay, so the coefficients. So there's a 1 on the x cubed, a negative 5 halves on the x squared. There is no x to the first, huh? Which means we need to add a 0 for the x to the first, and then we can put our constant in. So in our minds, we're viewing this polynomial as 1x cubed minus 5 halves x squared plus 0x to the first plus a half. Okay. All right, so 1 times anything is itself. So I'm just going to recopy it. Now remember, you can only combine like terms, so only these can combine with each other. Okay, so negative 5 halves plus 1. Looks like it's going to be negative 3 halves. And then that minus root 2 just has to stay. So let's just go and double check me. So negative 5 halves plus 1. Let's see here, negative 5 halves plus 1, negative 3 halves. Cool. Okay. So now we have to multiply these by each other. So that means that we have to do 1 minus root 2 times negative 3 halves minus root 2. So we're going to get negative 3 halves minus root 2. Negative times a negative is a plus. 3 halves times the root 2. And then a negative times a negative is a plus. And root 2 times root 2, that's u2. So let's go ahead and combine these together. So that's going to get you 1/2. And then remember there's a 1 in front of that. So basically we're just doing negative 1 plus 3 halves. So that's just going to be 1/2 also. Let me make sure that we check our fractions, okay? And also let me do a little. So let's check. Negative 3 halves plus 2. I said it was 1/2. Negative 3 halves plus 2. 1/2. And the other one that we did was negative 1 plus 3 halves. Just showing you guys on the calculator. All right, so that's what's going to go in right here. Here's the good news. We're adding 0 to it, so it's just going to stay the same. All right, and now we're going to go ahead and multiply these two by each other. Now, let me just kind of talk about the simplest way to get that done, because that is looking pretty nasty, right? Okay, so let's talk about that. So I have to take 1/2 plus 1/2 root 2, and I have to multiply it by 1 minus root 2. Well, here's what I'm thinking. What if I factor out the half and make this 1 plus root 2 times 1 minus root 2? That is going to be so much easier to do because these two are conjugates of each other, right? These are conjugates. Remember, with conjugates, you only have to do the first and the last. Root 2 times root 2 is 2, and a positive times a negative is a negative. Look at how much easier we made this on ourselves, right? So we got 1/2 times negative 1, which means we get negative 1/2. Oh my goodness, so much easier, right? And what do you know? The remainder is 0, and that's going to be the answer. So f of 1 minus root 2 is 0. All right, So there's some, combining like terms that could get a little hairy here. But once this trick of pulling out the half, once we did that, it was like, oh my goodness, so much better. All right. So as a consequence of the remainder theorem, a number is a zero if the remainder is zero when dividing. Okay, that theorem that we just used. All right, so we're just going to divide and see if the remainder is zero. It makes sense. So if I ever ask you, is it a zero? Just check and see if the remainder is zero. So we're going to substitute -3 in. And let's see, 3, 2, 1, and none. All of our exponents are there. So we're going to go ahead and put the coefficients. So 1's the coefficient on the x cubed. 2's the coefficient on the x squared. -5 for the linear term. And -6 for the constant. Let's drop down that 1. Multiply. Add. Multiply. Add. Multiply. Add. So the remainder was 0, right? So let's think about what that means. That means f of -3 is 0. Let me make sure I wrote it that way. Yes, I did. Okay, cool. So that's the definition of a 0, right? A 0 is a number such that when you substitute it in, you get 0 out, okay? So we're going to go ahead and say yes, okay? So since the remainder was 0, let's make this a little bigger. Since the remainder was 0, -3 is a 0 of f, we'll just say. Okay. Cool. Nice and easy compared to that square root one, right? All right, number 8. Use synthetic division to determine whether or not 8i is a 0. So I purposely put some square roots and some i's in here. So I didn't want to leave it to where you had to do them on your homework. I remember back in the day when I was going through school, the teacher would do, it seemed like the easy examples. And then the hard ones I'd have to figure out. And we didn't have YouTube. We just had the textbook. And often the textbook didn't do those. And so you'd have like the odds in the back. And yeah, so it took a bit. So I'd always be like, man, why isn't the teacher doing the hard examples? So I'm always trying to put in here fractions, decimals, radicals, whenever I can, okay? So it says determine whether it's a 0. Well, remember, it's going to be a 0 if the remainder is 0. So we are going to divide by 8i this time. We do an exponent check. Every exponent is there, 3, 2, 1, none. So let's just write down the coefficients. And this is good. We have a cumulative final. And so you'll want me to bring back things like I every so often just to keep it fresh, keep it in your mind. Okay, so we multiply. So that's going to get us 16i, right? Now we can't add these together and say 17i. That would be if this had an I on it. 1i plus 16i is 17i. It does not have an I, so they are not like terms, which means that we cannot combine them. So now we're multiplying these two together. So that means that we have to take 8i and distribute it into 1 plus 16i. So we got 8i, oh geez, 128, I think. And don't forget, I times I gets you I squared, right? So if you recall, I squared is really -1. And so this is going to be 8i minus 128. You can leave it like that. I mean, in the past, we've rearranged it, but we don't have to rearrange it in this context because we're just going to add downward. And what's nice when you add downward is these will cancel out, right? So we're just going to have the 8i remaining. Those will go away. So now we have to multiply 8i times 8i. So let's do that. So 8i times another 8i. 8 times 8 is 64. I times I is I squared. We know I squared is -1. So this is going to get us -64. Okay, so f of 8i was 0. The remainder was 0. So it is a 0. since the remainder was 0, 8i is a 0 of f. All right. Okay, you guys, that is it. Be looking for eventually a link showing more examples of some long division and some maybe some synthetic division. All right, thanks for joining me, you guys. Take care.